All right, so here's our study guide for tomorrow's quiz. So like I said, I've uploaded it to Focus, and it's on our webpage. You can take notes on a clean piece of paper as well. So problem number 1 right here asks to identify the choice that best completes a statement or answers the question. Which choice shows a, be careful when you read this, which choice shows a true conditional with the hypothesis and conclusion identified correctly? So the conditional has to be true, first of all. So answer choice A says, yesterday was Monday if tomorrow is Thursday. Well, that's not true, is it? So we're not going to pick A. Answer choice B, if tomorrow is Thursday, then yesterday was Tuesday. Now that statement's correct, isn't it? Mm-hmm. The hypothesis, though, says that yesterday was Tuesday. Well, the hypothesis is supposed to follow the if. And in this case, after the if, we've got tomorrow is Thursday. So this has not identified the correct hypothesis and conclusion. Answer choice C. If tomorrow is Thursday, then yesterday was Tuesday. All right, well, that's true. Hypothesis. Yesterday was Tuesday. Well, again, the yesterday was Tuesday follows the then. So that's an incorrect hypothesis. So it only leaves one more choice. But this choice is not the way you'll typically see an if-then statement. Yesterday was Tuesday if tomorrow is Thursday. All right, what follows the if is tomorrow is Thursday. So first of all, this statement, yesterday was Tuesday if tomorrow is Thursday, that's true. The hypothesis is what follows the if. So tomorrow is Thursday is the hypothesis. That's identified correctly. The rest of the statement is the conclusion because there's not a word then. So yesterday was Tuesday is the conclusion. That works as well. So answer choice D. All right, it's not a difficult question, but it can be tricky if you don't read it carefully. So be careful on that one tomorrow. All right, problem number 2. What is a counterexample for the conjecture? A counterexample. It shows a statement to be incorrect. A counterexample is an example of something that shows that this conjecture is not correct. So any number that is divisible by 4 is also divisible by 8. So we're trying to think of an example that shows that that's not true. Any number that is divisible by 4 is also divisible by 8. So the first thing that I think of are the numbers divisible by 4. And you've got 4, 8, 12. Well, 12 is divisible by 4, but is it divisible by 8? It's not. So you can just say 12 is not divisible by 8. Counterexample shows a statement to be incorrect. All right, problem number 3. What is the conclusion of the following conditional? All right, so again, hypothesis follows the if. Conclusion follows the then. Or if there's no then, it's the rest of the statement. So a number is divisible by 3 if the sum of the digits of the number is divisible by 3. A number is divisible by 3 if the sum of the digits. So look, What follows the if is right here. The sum of the digits of the number is divisible by 3. That's your hypothesis. It follows the if. Now, there's not a word then in this statement. So if there's not a word then, we use the rest of the statement as the conclusion. So that would be what's in blue right here. So when they ask for the conclusion, it would be a number is divisible by 3. Oops. All right, problem number 4, identify the hypothesis and the conclusion of the conditional. Again, the hypothesis follows the if. So I'm going to use highlighters right here instead of rewriting this statement. So the hypothesis I'm going to put it in yellow. The hypothesis would be 2 lines intersect at right angles. The conclusion. The conclusion follows the then. So the 2 lines are perpendicular. All right, yellow is hypothesis, blue is conclusion. Remember those symbols we did yesterday? You read this symbol as if P, then Q, where P is also the hypothesis, and Q is the symbol for the conclusion. All right, problem number 5 has 3 parts to it. 3 answers to fill in. Another name for an if-then statement is that's conditional. Every conditional has 2 parts. The part following the if is the hypothesis. And the part following the then is the conclusion. And these answers, these 3 answers are in all of the first 4 questions. Okay? Identify the hypothesis and conclusion of this conditional statement. All right, in problem 3, what is the conclusion of the following conditional? So all these statements are conditional statements. All right, problem number 6. Write this statement as a conditional in if-then form. So you've got a little bit of leeway here, but we can say that we're talking about triangles, all right? And we're talking about the fact that triangles have 3 sides. So if a figure is a triangle, That covers the first part of the statement, a figure being a triangle. Then it has three sides. If a figure is a triangle, then it has three sides. You don't necessarily have to use the word figure. All right, you could use the word shape. You could use polygon. All right, if a polygon is a triangle, if a shape is a triangle. Bottom line is that if it's a triangle, then it's got three sides. All right, in problem number 7, you're asked what is the converse of the following conditional? And in your notes yesterday, we had that table of related conditionals, and a converse if Q then P. The converse of a statement is when you switch the original hypothesis and conclusion. So look, if we go back to hypothesis in yellow, if a point is in the first quadrant, so here's our hypothesis, a point is in the first quadrant. What follows the then is the conclusion. So the conclusion here would be its coordinates are positive. All right, hypothesis is in yellow. Conclusion is going to be in blue whenever my coordinates are positive. So we need to switch these two. So we're going to say if the coordinates of a point are positive, then it is in the first quadrant. The converse of a conditional statement is still in if-then form, but you just change the hypothesis and the conclusion. You make the original hypothesis, follow the then, you make the original conclusion, follow the if. You adjust any of the other smaller words to make the statement still have the same truth value as the initial statement. All right, then mixed in here at this quiz are a couple of these vertical angle problems. All right, we talked about vertical angles earlier in the year, so this is a little bit of a review. Vertical angles are formed by two lines, and they hold positions opposite of each other. So this angle, 7x minus 8, and the angle 6x plus 11, they're opposite of each other. They're formed by two lines, so they're congruent. The left and right angles in this diagram, those are called vertical angles, and those are also congruent to each other. So they're asking for you to find the value of x. So 7x minus 8 is equal to 6x plus 11. Subtract 6x from each side. So x minus 8 is equal to 11. add 8 to each side. So we get an x that's equal to 19. Vertical angles formed by two lines, and they hold the opposite position of each other. Problem 9 is very similar. What is the value of x? Again, you've got two lines. These angles here are congruent to each other because they're opposite of each other. So this 3x minus 10 is equal to 149. Can add 10 to each side. Three x is equal to 159. And then divide both sides by 3. So x is equal to 53. All right, problem number 10 asks you to find the values of x and y. So again, we've got pairs of vertical angles. This angle right here on the left is congruent to this angle on the right. So our 7x plus 7 is equal to 112. If we subtract 7 from each side, we get a 7x that's equal to 105. And then divide both sides by 7. So our x is equal to 15. Now, as we're looking at this diagram, does everybody see this vertical line, line L right here? Line L is a straight line. Straight lines measure 180. We need to solve for this y. We need a 4y that's equal to something. Well, 4y, this angle right here, is equal to this angle. And this angle, all right, this light blue angle right in here, is equal to 180 minus 112. Those two angles, the 112 and the blue one, form a straight line, so they're a linear pair. And 180 minus 112 is 68. So this 4y angle and the blue angle are congruent to each other. So 4y equals 68. If you divide both sides by 4, then y is equal to 17. So there's your x and there's your y. And problem number 11. All right, what are the converse, inverse, and contrapositive of the following true conditional? What are the true values of each? If a statement is false, give a counterexample. The conditional that they've given you is two angles that have the same measure are congruent. So they don't give you the word if and they don't give you the word then, but you can take this information and you could insert an if and then. So we're going to say that our conditional, our if then, is going to be if two angles have the same measure, then they are congruent. And I'm going to use the symbol for congruent so I don't have to keep writing that word. So I took the information given. It is a conditional statement, but I rewrote it with the word if and with the word then so that we can identify, look, we're going to go hypothesis again. Hypothesis is what follows the if. Two angles have the same measure. Conclusion follows the then they are congruent. All right, conclusions in blue, hypothesis is in yellow. So now we have to write the converse. The converse switches the hypothesis and the conclusion. Here's our converse symbol, if Q then P. So now we can say if two angles are congruent, then they have the same measure. All right, we switched the hypothesis and the conclusion. So now, what are the truth values of each? If two angles are congruent, then they have the same measure. That's true. So that's its truth value. It's true. Inverse, the symbol for inverse. If not P, then not Q. We're going to negate the original hypothesis and conclusion. We do that by inserting the word not. So we can say if two angles do not have the same measure, then they are not congruent. All right, we took the original conditional statement and we negated the hypothesis and the conclusion. So if two angles do not have the same measure, then they are not congruent. That's true. Congruent angles have the same measure. All right, then the last statement is the contrapositive. And the symbol for contrapositive is if not conclusion, then not hypothesis. So the easiest way to do this is to go back to the converse and negate it, because the converse was written if Q, then P. The contrapositive is written if not Q, then not P. So go back to the second statement and negate it. So we can say if two angles are not congruent, then they do not have the same measure. All right, and if two angles are not congruent, then they do not have the same measure. That's true as well. So all of the statements ended up being true. No need to list a counterexample. All right, and that completes your study guide for this week's quiz.